All right, there we go. So in this video, we're going to be talking about metric units, and we want to be able to distinguish between mass and weight and identify the metric units of mass, length, and volume. All right, so here we go. Mass and weight are directly proportional to each other. Mass is the measure of a quantity of matter. And weight is a measure of the force of gravitational attraction. So it's proportional to mass, but it depends on where you are in the universe. But fortunately for us, this proportionality is constant over the face of the Earth, or the surface of the Earth, I should say. So when we weigh something in the laboratory, we express its weight in terms of mass, or as its mass, I should say. And the SI unit for mass is the kilogram, all right, which is defined as the mass, of a platinum, iridium cylinder stored in a vault in France. So if you wanted a fun fact to know, there you go. And a kilogram weighs 2.2 pounds, just to kind of put it in perspective. But for most laboratory work, that's a lot of chemicals to work with. We work in much smaller quantities. So the basic metric unit usually used is a gram, okay? And really, what's the difference between a kilogram and a gram? You know, why, other than their quantity, what does this kilo mean? In other words, what's going on there? Well, in the metric system, units that are larger than the base unit are larger by multiples of 10. Okay, and units that are smaller than the basic unit are smaller by fractions that are also multiples of 10. So this is a really big table that kind of shows all of this, where you have a metric prefix here like kilo. Okay, it has this symbol K, and remember that was in front of the symbol for gram, G, kilogram. And it says here its multiple is 1,000, which means, and we'll see this as we go to some examples, that there are 1,000 grams in 1 kilogram, okay? So there's other examples here like a milli, right, milligram. Oh my goodness. Okay, so this one would be that 1,000th of a gram is 1 milligram. Okay, so again, it's a multiple of 10. We're going to see some examples of this as we go on. This is just to introduce it to you first, and then we'll go from there. All right, so before we do that though, let's define our other two units that we're missing here. So length, the SI unit for length is a meter. Okay, this is how it's defined. It's defined as the distance light travels in a vacuum, okay, in this incredibly fast time. So a meter is 39.37 inches, or 1 inch is defined as 2.54 centimeters. This is a good conversion to know. We're going to be using that quite a bit. So commit that one to memory, maybe write it down in a sticky note that you can have it with you as you take quizzes and tests, so you know that conversion. Okay, so that's length, right? In the metric system, it's a meter. Volume, all right, its SI unit is a cubic meter, all right? So length times width times height of a cube is its volume. And for more practical laboratory units though, we use a cubic centimeter. So kind of the same idea. A cubic meter is quite a lot of material to work with in the lab. We work with smaller quantities. So we're going to use a cubic centimeter as the SI unit for volume. Now, 1 liter is defined as exactly 1,000 cubic centimeters. Okay, that's shown here. All right, or there's a few other ways you can think about this. 1 milliliter is 1 cubic centimeter. They're the same. Or 1 liter is 1,000 milliliters. And that's that little prefix milli in the front of a liter. Again, so that prefix tells you the multiple if you go on that chart. Okay, so now we have grams, we have meters, we have cubic centimeters, which you could also call milliliters, okay, or liters if you're dealing with meters cubed. I may have said centimeters squared. I didn't mean to say that. Centimeters cubed, excuse me. If I said that throughout the video, ignore me. It's getting kind of late here. Cubic centimeters. All right, so now let's go through what we really need to know. I don't want you to know that whole table of converting between these things. But before we do that, I guess, let me state the goals for converting between things in the metric system. So here's the goals. We want to stay and write the metric prefixes and the relationship between the two, a kilo unit, a centi unit, and a milliunit. Using this table 3.1 that I'll show you in the next slide, state and write the appropriate metric prefixes, and then given mass, length, or volume expressed in metric units, express the quantity in other units. So that's what I was just saying now. How do we put all this together and kind of use this for problem solving? Excuse me. All right, so here's the table I really want you to know. Not that big one on the other slide. This one breaks it down. And so here's the metric relationship, and here's the example. All right. So there's 1,000 units of anything per kilo unit. All right. So this could be 1,000 grams, 1,000, let's see here, 1,000 meters, okay, per kilogram, per kilometer, okay? So 1,000 units of anything per kilo unit. There's 1,000 centi units per unit, or not 1,000, excuse me, 100 centi units per unit. Whew. I need to quit here in a second. All right, so this means that there are 100 centigrams per gram, because remember our base unit would be gram, 100 centimeters per 1 meter, okay? Those are our base units. Or 1,000 milliunits per unit. So this means there would be 1,000 milliliters per 1 liter, right? This is true for anything. There's 1,000 milligrams per 1 gram. Okay. There's 1,000 millimeters, per 1 meter. Okay. So this is our conversion factors that we need to know when we do these problems. And we would express them as a per expression, which is something that we talked about before. So this is 1,000 milliunits, 1,000 milliliters per 1 liter, 100 centigrams per 1 gram, right? 1,000 meters per 1 kilometer, okay? So again, these are the examples that I want you to use as common metric relationships. So let's do a problem then. We're going to do this the same way we did before. How many centigrams are in 0.87 grams? To solve this problem, we're going to use dimensional analysis, okay? So let's do this together. So let's write down what's given. We're given 0.87 grams, okay? And what do we want? Well, the unit of what we want is in centigrams. You know what? Let me not spell this out. Let's get used to seeing grams represented as it will be throughout the semester with this unit G. Okay? And what's our conversion between the two? Well, I know if you go back to the table that there's 100 centiunits, right? So centiunits or centigrams per 1 gram, okay? And my path, I want to go from 0.87, well, that's a 9. And now it's a mess. So let me fix this. 87 grams to centigrams. Okay, so let's write this out. 0.87 grams times 100 centigrams, 1 gram equals Notice that the units of grams cancel. I'm left with centigrams. So I plug this in my calculator. I get 87 centigrams. That's my answer. Let me just double check that in my calculator. One more time. 0.87 times 100. Yep, 87 centigrams. Okay. So that's an example of using dimensional analysis. Again, here it is again, to convert within the metric system. Okay, that's our first example. Let's do another example. So pause the video, do this one on your own. How many kilometers are in 2,335 meters? So pause the video, try to do this problem. Okay, so what are we given? Well, again, 2,335 meters. We want kilometers. Our per path here is that there's 1 kilometer per 1,000 meters. Okay, and the path is 2,335 meters, 2 kilometers. Okay, so if I write this out, times, there's 1,000 meters, 1 kilometer. Notice that the units, again, I'll keep saying this, of meters cancel. I'm only left with kilometers. So when you plug that in your calculator, you should get 2.335 kilometers. And I hope you got that. Okay. So again, this is pretty easy, right? This is converting between one thing to another, all right, using dimensional analysis. So final problem, do this one on your own. And again, let's check it together. So pause the video and then we'll go from there. Okay, so how many milliliters are in 0.00339 liters? Again, let's go through this one kind of fast. 0.00339 liters. I want milliliters. My per path, I know that there's 1,000 milliliters, 1 liter. So that's the per expression. The path, 0.00339 liters to milliliters. So I can write that out, 0.0339 liters times 1,000 milliliters, 1 liter. Units cancel. And so I'm left with 3.39 milliliters. So that's my answer. Okay. So, oh, there's actually one more. So bonus problem. So why don't you give that a try? How many centimeters are in 0.045 kilometers? All right. So why don't you do that one? Actually, this one should probably be pretty good. And this should be the last one. I forgot this one was even on here. So do this problem. Okay. So this one's actually a little trickier. So I'm glad this is on here. 0.045 kilometers. Hope you got the right answer. We want centimeters. I know from my table before that I can convert between kilometers and meters, right? So for every 1,000 meters, there's 1 kilometer. And I know that I can convert between meters and centimeters. So for every 1 meter, there's 100 centimeters. Okay? So the path I'm going to take, I'll write it over here. We want to go to meters, and we want to go to centimeters. Okay? So let's write this out as an algebraic expression. Kilometers. I'm going a little bit faster now, just since this is the last example. Okay, 1,000 meters times, for every 1 meter, 100 centimeters. Okay, Units cancel, cancel, cancel. I'm left with centimeters. So I know I did it right. And I didn't have the answer written down. So let me get out my calculator. Okay, 0.045 times 1,000 times 100. So I'm getting 4,500 centimeters. Okay, and if I wanted to express that in exponential or scientific notation, just to get us some practice doing that too, 4.5 times 10 to the 3 centimeters. Okay, and that's just, again, moving the decimal, not to prolong this, 1, 2, 3 places over. All right, so I think that's it. That's it for this section. Hope you enjoy the rest of your week, and we're going to be continuing in chapter 3 next week.